Now that we've examined angles of all different sizes, much smaller than 0 degrees and much bigger than 360, we can sort of look at our Cartesian plane in a new light and know that we can draw a ray anywhere on it and describe the angles that would be associated with it. Now we want to draw a circle, and the reason that we're going to do that is circles have this lovely property of having a radius that's always the same. So if we want to describe a ray and we know that it goes through the origin, all we really need is some point somewhere on this circle as the other point that it goes through, and that would then describe a line, wouldn't it? And that would describe a ray and then all the associated angles as well. So if we just choose any random point on this circle, let's call it P for point, that point will have an X value and a Y value, won't it? Now if we drop a perpendicular line straight down from P until it hits the X-axis here, and then if we actually draw in a radius of the circle that goes straight out to P, what we've got here now is we've got a little ray, don't we? We've found a point on the circle and we've made a ray. And so we can call this theta. Now, if we want to describe the rest of the sides of the triangle, it's not too hard really, because if this point is x, y, this distance here must be x, mustn't it? Because this is the x value of that point up there. So this length is x. And if we want to see how tall this line is, well, it goes from 0 all the way up to y. So the length of that line is y. And how long is this line? Well, it's a radius of our circle, so we can just call it r for radius. And you'll notice I've labelled r, r, minus r, and minus r around here for when we want to consider this triangle being in one of the other quadrants. We call these quadrants of the circle, or of the Cartesian plane. Now that we have our triangle, and it would be a right angle triangle, wouldn't it? Because we dropped this line straight down perpendicular to the x-axis. We can now come up with something of an expression based on this triangle for each of our trig functions. So if we're going to find sine theta first, sine theta is opposite over hypotenuse, so we'll have y over r. Cos theta will be adjacent over hypotenuse, x over r. Tan of theta, opposite over adjacent, so we have y over x. And then to find these three reciprocal functions, we literally just take the one that's associated with it and flip it upside down, don't we? So cosec, third letter s, it's related to sine. So instead of y over r, it will be r over y. Sec, third letter, it's related to cos, remember? So instead of x over r, we'll have r over x. And cot is related to tan, so instead of y over x, we have x over y. All right, let's get those down.